Let's take a look at chapter 11 that deals with statistics. We're just covering a few basic things from there. All right, I wanted to look at first creating some charts and graphs to display data. Graphs and charts can be just really useful to organize your raw data in a form that allows people to see what's going on and to look for trends and that sort of thing. Okay. So first thing I wanted to do is look at this problem where we're being asked to try to create a frequency distribution for this data. So what we have are categories that consist of blood types, and we can just count how many of the 25 volunteers had each of those blood types. So when you're trying to do that, sometimes what's helpful, okay, this is kind of hard to write on the screen, so forgive my handwriting a little bit. So the first thing you want to do is think about your categories. So you're going to have these various blood types, and we've got blood type A, B, AB, and O. And then what'll help is for us to tally, okay, up, to just make a tally mark, and just like a line every time we encounter an A, and then do the same for B, for AB, and for O. And then we can come over here and complete and count them and come up with the frequency. Let's see, can't fit that. Let me change this just a little bit. All right. So we'll have our blood types here. I'm just going to start that over again. Just give me a second. Okay, so I'm going to put the different blood types I'm going to be counting. Then I'm going to do a little tally. And then I'll add up my tally marks to get the frequency. Okay, so we have the 4 blood types, A, B, AB, and O. And what you can do is just kind of go through. Okay, there's an A, 2 B's, an AB, an O, 2 more O's, a B, an AB, and so on. And so I'm going to continue doing that. I'm just kind of tallying up how many I have. Go ahead and get that one. I like to cross them out once I do them, so I don't double count. And I don't really like to talk while I'm doing it because I mess up. That was 3 O's, 1, 2, 3. And then I have another AB. Okay, and then I like to check. So there's 5, 10, 15, and 4 makes 19, and another 4 makes 23, 24, 25. So I think I counted them up and didn't skip any. And then you just write how many that is. So that's 5, 5, 6, 7, and then 4, and then here I have 9. So that little middle part of it is really not part of your frequency distribution, but it's like your something that's helpful. It's like scratch work you could do. So then you'll just kind of ignore that, and your frequency distribution is like blood type A with 5, blood type B with 7, and so on. All right, and then I wanted to take a look. Here, the data we were looking at was not really numerical data. It wasn't like time and years. It was categories of things, different blood types. All right, we're going to look at one that's used when you have numerical data. This one is called a grouped frequency distribution. So we divide the data into classes, and then we go ahead and count up how many fit each of those classes. So we're not actually going to do this one, but you can read about it right here. So like if we were collecting data on the weights of people, something like that, then we might cluster the weights into weight ranges, like 100 to 119. Or 120 to 139. And then we'd go through, we'd count up how many people had weights in those ranges. Okay? But we're not going to do that. They're not hard. It's just we got to limit what we touch on here. The point of this first part is how you can take raw data and begin to try to make it meaningful by trying to organize it in some way. Now, this is one that I really want you to look at. This is sometimes called a stem plot, but more often called a stem and leaf plot. So it's pretty cool. You can use it when you're trying to take data and organize it. It's surprising the kind of information that you can get after looking at a stem and leaf plot. So what you do with that, here we're going to take this data about COVID-19, adults that have been fully vaccinated against COVID-19, the percent of adults that have been fully vaccinated, and we're going to create a stem and leaf plot, okay? And so what you do is you literally have one part that you call the stem, and then you have another part that you call the leaf. Now, I like to do a scratch work stem and leaf, and then I'm going to clean it up once I get the scratch work done. Okay? So the first part can be time consuming because you've got potentially a bunch of raw data that you're trying to organize. So when you look at this, see how these are 2 digits representing a percentage? So like Massachusetts, 62% were fully vaccinated. So we're going to take that 62, and you always want your leaf to have just 1 digit, okay? So when I do 62, I'm going to put like a 6 followed by a 2. But what I want to do is first survey all of this data. So I'm looking at all of these, and I'm looking at largest and smallest, the gist of what I've got there. And I don't see anything that starts with a 2 or a 0 or a 1. So I'm going to go ahead and have my first stem be a 3, and that represents 30%. And then I'm looking at how I would then want a 4, a 5, and I also see some with 6, but I don't see any with a 7, okay? And then what I can do is just go in here and start recording the data, okay? So 62, 47. Now this is my scratch work one, so I'm just going to go through, and I'm going to take all of these and put them where they belong, and then I'll organize it better in a moment. Okay, so you can begin doing the same thing. And if a number like that one occurred more than once, you write 5 more than once. Then I had a 54 one time, 42, okay, a 39. So I'm just going through and putting it in the correct spot, and then I'll clean it up in a moment. 39, 45, 35. This allows me to kind of go fast when I'm getting the stuff into the right category, because I can see quickly what it starts with. And 35, okay? And then once I get them written down, then what I want to do is get them organized. So I'm still going to have, let me change the color to something new, okay? So I'm still going to have the same stems. I didn't wind up needing any other stems. And I'm just going to put the leaves that you see in order from smallest to largest. So I had a 0, 2 5s, 2 7s, I had an 8 and 3 9s. Okay, then I'm going to do the same on each of these. Okay, you don't put commas between the leaves or anything, and if a number occurred more than once, you're going to have the leaf, you will have the leaf have the same digit more than once. Just tells you it occurred more than once. I hit something, kept it from drawing. Let me try again. There we go. 2 2 4 4 2 2s, 2 4s, 3 5s, a 6, and a 9. And then the 6 had a 2 and a 6. Okay. Now, you really should also have a legend or a key. And the key for this would be you take a number like 42% and you tell people that this right here means 42%. So they know how to interpret it. Okay. So a couple things to note. Only one digit for the leaf. Okay. No commas. No commas. And put the leaves in order. Okay. Are a couple things to remember. Now the cool thing is if you turned that graph, if you just take your paper and you turn it sideways, I can't really show you that part, but if you just take that paper and turn it sideways, then you basically get, maybe I can, let me see if I can, well, I won't try, but if you look at it sideways and if these were written in the same size, right, so that you could see how many there were, you'd have a sense of the distribution of the data. You could almost look at it like a line graph in a way. All right. All right, and now we're going to look at both of those are almost like frequency distributions. The stem and leaf even is like a frequency distribution. It's just a kind of a special type, but it tells you like how many data values there were in each category, like in the 30%, in the 40%, and the 50%, and the 60. So they're all similar in that way. I like to think of the stem and leaf being kind of in between just doing a tally and or a frequency distribution and making a graph. Because like I said, if you turn it sideways, it kind of has, it almost looks like the graph we're going to see in a moment.